All right, so notes 2 for chapter 4, binomial distributions. So a binomial experiment, it's a probability experiment that satisfies the following conditions. So the first one is the experiment has a fixed number, so a set number of trials. So how many times it can be done, where each trial is independent of the other trials. Independent of the other trials. So that's the first one. So the experiment has a fixed number of trials, so some number of times that it's done, where the trials are independent of each other. Okay. So the second one, there are only 2 possible outcomes of each trial. It's either going to be a success or a big failure. So success or fail. So that's the second one. There are only 2 possible outcomes for each trial. They'll either be a success or a failure. So S or F. So then the third one, the probability of success is the same for each trial. So that's the third one. The probability of success is the same for each trial. And then the last one, the random variable, which we use X, counts the number of successful trials. Okay, so those are the 4 things. So the fourth one, the random variable X counts the number of successful trials. So the first one, again, the experiment has a fixed number of trials where they're independent of each other. Second one, there are only 2 possible outcomes of each trial, success or failure. And then third, the probability of success is the same for each. And the last one, your random variable X that we've been talking about, counts the number of successful trials. Okay, so notation for your binomial experiments I gave you. So N is the number of trials. P, lowercase p, is your probability of success in a singles trial or in a single trial. Let's make that proper. Q is the probability of failure. So 1 minus p. Okay, so if p are your successes, then Q would be the difference of that. And X is that random variable we just talked about that represents the count of the number of successes. So it'll be some number in your experiment. Okay. So looking at example 1, from a deck of cards, you pick a card, note whether it is a club or not, and replace the card. You repeat the experiment 5 times. So N equals 5. The outcomes of each trial can be classified into categories. You've got success selecting a club, failure selecting another suit. The probabilities of success and failure are, and so we're going to go ahead and do that. So if you remember, there are 4 suits. Okay. So 4 suits, 52 cards in a standard deck. Okay. Each suit has 13 cards. Okay, so that was something from our last chapter that we did discuss, that there are 13 cards in every suit. So 4 suits, that gives you 52 cards in your standard deck. Okay, so if you look for your successes, okay, if P is your number of successes, or the probability of success, I'm sorry, probability of success, you've got 52 cards, right? Okay, 52 cards. Out of those 52 cards, 13 are clubs. And you have 52 cards total. So that means 1/4 of them, 1/4 of them are clubs. So the probability of getting a club is 1/4. And then the probability Q, and Q is our probability of failure. The probability of not getting a club would be 3 out of 4. Okay. So remember, Q is 1 minus your P. So 1 minus 1/4 is 3/4. Okay. So you've got the outcomes, whatever you choose, you would mark them S, selecting a club, so success, and then failure would be selecting another suit. Okay, but we're, P and Q do the same thing and they go with our binomial distributions. So we can label them like this. So is this the probability of success? Nodes are fine. Probability of failure. Okay. And then the random variable X represents the number of clubs selected in 5 trials. So the possible values of the random variable are. So if you're talking about the possible, if X is the random variable that represents the number of trials, or the number of clubs you get within those trials, number of clubs you get within those 5 trials, you could pick 0 clubs. All 5 trials, you don't get one. So no, I'm just going to put C for clubs. Okay. You could get 1 out of everything. You could get 1 club. You could get 2, 3, 4, and you could pick all 5 clubs through your trials. So if we said, for example, X was equal to 2, that means 2 of your 5 trials or cards chosen you picked clubs. Okay. All right, so we're going to take a look at example 2. Determine whether the experiment is a binomial experiment. If it is, we're going to specify our number of trials, successes, and our failures, and then list the possible values of our variable X. If it's not, we're going to try to explain why. Okay. So a certain surgical procedure has 85% chance of success. A doctor performs the procedure on 8 patients. The random variable represents the number of successful surgeries. So if we're looking at this, we need to ask ourselves, does it require all 4 conditions of the binomial experiment to do this problem? And this one does. you have trials, which is your N. So N here is going to be the number of patients. That's your trials. Okay, he does it on 8 patients, which is your N value. It gives you a success rate of 0.85, which also means you have a failure rate, Q, which is 0.15. Okay. So if you take away the 0.85 from 1, the failure rate is the 0.15. Okay. So then your random variable x, okay, is the number of successful surgeries. You could go from 0, 1, 2, all the way to 8. You could have 0 successes. You could have all 8 successes. But your random variable will be anything from 0 to 8 inclusive. So take a look at 2 and try to do 2 on your own. All right, so you had some time that you could work on number 2. This one is not a binomial experiment because of the without replacement. What this does is it changes the probabilities for each success. So if you don't choose a red marble after the first time, you still have 5 in there, but you've taken out one of the blue or the green, so you're left with 19. And then the third trial, same thing. If you haven't picked a red marble out yet, you've picked another blue or green, you're not putting it back, which changes the probability. So it doesn't follow the third qualification that we wrote down. It breaks rule number 3. So take a couple minutes, pause the video, and try the U-try, and I'll put the answers up. All right, so if you took some time and paused the video, these are the answers that you should have. You should have N equals 10, E equals 1/4 or 0.25, Q is 3/4 or 0.75, and our random variable can be anywhere from 0 questions or 0 correct answers to 10 correct answers. So just make sure you have those numbers. And if you have any questions, come see me. All right, binomial probability formula. So the probability of exactly X successes in N trials, we have this formula. So probability of X, we've got N, big C, little x, P to the X, and then Q to the N minus X. So you've got your successes and failures in there. You've got your number of successes and your N trials, and you have your combinations that we talked about in our last unit. So what that also equals, you have N factorial, so number of trials. So number of trials minus your successes factorial times your successes factorial, P to the X, and Q to the N minus X. So just as a reminder, your number of failures is the N minus X. It's showing if you have X successes, you take that away from your number of trials, you should have your failures. Okay, so that's our formula. We're going to show exactly how to use it in just a minute. All right, we're going to jump down to You try 2. So a card is selected from a standard deck and replaced. The experiment is repeated a total of 5 times. Find the probability of selecting exactly 3 clubs. So we're going to jump down to this part. What does one trial consist of? We're just going to put in some information that we know. How many trials are there? We know that there are 5. Okay. We know a success is P. And we're going to stop there.